Now I'm moving to two-way ANOVA. We use two-way ANOVA when we are having two factors. Suppose in our diet food example, we are also having the laboratories data. So now I will be having two null hypotheses. One for the diet food, second for the labs. My first null hypothesis will be mean of diet food A is equals to mean of diet food B equals to mean of diet food C equals to mean of diet food D. My alternate hypothesis will be at least two means are not equal. Similarly, for labs, I will be having my second null hypothesis. Mean of lab 1 equals to mean of lab 2 equals to mean of lab 3, which means average cholesterol content in the three labs is same. My alternate hypothesis will be at least two means are not equal. Now I'm moving to my Excel workbook. As you can see, in the rows, I have diet food A, B, C, and D. In columns, I'm having lab 1, lab 2, lab 3. Go to data, data analysis. You can see ANOVA with replication, without replication in case of two-factor. I will be using ANOVA two-factor without replication. Okay. I will select my range. Yes, there are labels in the data alpha new workbook. Okay. As you can see, both p values are less than my level of significance, which I have taken at 5%. Hence, both my null hypothesis can be rejected. So I can say there is a difference in the average cholesterol content due to various diet foods and because of the laboratories where the measurements were taken. Let's take one more example. Suppose I have the data of debit card payment, credit card payment, RuPay and bank transactions in Delhi, UP and Haryana. And I want to know whether there is a significant difference or not. Go to my data analysis without replication. Okay. Select your range, labels, alpha. Okay. Again, you can see your p values are less than your level of significance at 5%. Hence, your null hypothesis can be rejected, or you can say you have enough evidence to reject your null hypothesis. Now, when I want to capture the interaction effect, I will be using the two-way ANOVA with replication. Here, I will be having three hypotheses. For example, you want to know the difference in the pay packages offered to various fresh MBA graduates. The variation could be either due to the type of business school where they have studied, or it could be due to their area of specialization. The variation could also be due to an interaction between the business school and area of specialization. I will be having three null hypotheses now. The very one for the business school, where I will be taking average pay packages for all the institutes are equal. In alternate, I will be having average pay packages for all the institutes are not equal. Similarly, I will be having it for the specialization. I will say average pay packages for all the specializations are equal in my null hypothesis. In my alternate, I will say average pay packages for all the specializations are not equal. Similarly, I will be having my third null hypothesis. Average pay packages for all 12 interactions are equal, whereas in my alternate, I will be saying average pay packages for all 12 interactions are not equal. How this 12? For this, I will be moving to my Excel workbook. As you can see here, I'm having 3 specialization: marketing, finance, and operations. And I'm having 4 institutes: 1, 2, 3, 4. So 12 means 3 into 4. Go to the data analysis. Now, as I want to capture the interaction effect, I will be using with replication. Press OK. Select your input range. I'm having 2 rows per sample. How? Marketing 2, finance 2, operations 2. Alpha, I'm taking at 5%. New worksheet, press OK. You will be having the tables. And here you can see all p-values are less than the level of significance. Hence, all my 3 null hypotheses have been rejected. So, I can conclude that packages offered to fresh MBA graduates differ due to their specialization, the type of business school in which they have studied, as well as the interaction between the specialization and business school. So, I can capture the interaction effect with the help of Anova two-way with replication.